In the last video, we talked about enzymes and really what they are and what their functions are. And in this video, we're going to do some examples based on what we really learned in the last video. So here we have question number 1, and it says, what is the main function of an enzyme in a chemical reaction? Well, I mean, before we even look at any of these choices, we already know a lot of things about enzymes. Enzymes, we know, are specific, special proteins, and what they do is they speed up chemical reactions. And so over here, I brought back the image from the last video. And what it's trying to show is this is the energy on the y-axis, and this is the reaction coordinate on the x. And what it's trying to show is that the initial amount of energy needed with and without the enzyme is different. With the enzyme, the activation energy, which is the initial energy needed to activate the chemical reaction, um, is lower with the enzyme than without. And this is because it takes less energy in order for the chemical reaction to occur. And so that's what enzymes do. They speed up reactions. So instead of using all this energy over here, oh, slipped a little bit, you only use a little bit of that energy. And so that's what enzymes really do. So back to the question. It says, what is the main function of an enzyme in a chemical reaction? Well, let's read the choices now that we reviewed very quickly what an enzyme does. To slow down the reaction. Well, no, that's the complete opposite, in fact. Enzymes speed up the reaction. So A, we can safely eliminate. B, to increase the temperature. Well, no, we really never talked about increasing temperatures. Enzymes do not increase the temperature, so we can eliminate B. C, to decrease the activation energy. Well, yeah, that's literally what we saw in the graph over here. We saw the activation energy is so much smaller, so visibly smaller in with the enzyme than without. So yes, C would be right. C would be right. And just to be safe, let's check D. D, to become the final product. No, that's not what an enzyme does. All right, let's do another question. What type of macromolecule are enzymes made of? Okay, so macromolecules, they're really just what are enzymes made of? You don't really need to know what macromolecules are. And we will talk about what macromolecules are and the types of macromolecules in future videos. So what type of macromolecule are enzymes? Well, enzymes we already said are specific special proteins. So they are proteins. So carbohydrates? No, no. Proteins, yes. Lipids? Nope, that's not it. Nucleic acids? No. And we will discuss all these macromolecules in other videos. Let's do another question. What is the term for the molecule that an enzyme acts on? So what it's trying to say is, what does an enzyme bind to in order for a chemical reaction to occur? Well, we already said if I have an enzyme over here and I have some specific shape, I don't know, like this, and then something like this, and like this again. Well, this is an enzyme. This is my enzyme with its specific shape. It binds to something called a substrate. And we talked about this. It has the same shape, so it fits into exactly the same place as the original enzyme. So this is called the substrate. And we talked about this and discussed enzyme substrate complexes in the last video. So what is a term? Well, we just said substrate. So inhibitor, no, that's wrong. Product, no. Catalyst, nope. Substrate, that's the answer. Let's do another question. What happens to most enzymes if the temperature gets too high? Well, we quickly actually discussed temperature and pH and that the effects on enzymes due to temperature and pHs. And so we said that the higher the temperature, when temperatures get too high, too is really the specific word here we're looking for. When it gets too high, the enzymes really become denatured and they might lose their shape. So instead of an enzyme looking like this, the one up here, it would maybe lose its shape. Maybe a corner like a point would just be removed, and so it wouldn't bind to that specific substrate. So it would become denatured and it would lose its shape and function. So they work faster? No. They become denatured. That's the key word here. Yes, they become denatured. B is our answer. They freeze? No. They become substrates? No, that's not the answer. Let's do another question. Which of the following best describes the enzyme substrate relationship? We talked about it in the last video and we kind of showed it in up top. And what it's really like a lock and key. It's like the key is the enzyme and the lock is the substrate. And the enzyme binds to the substrate because enzymes are so specific. They only bind to specific substrates. So let's see. Random fit model. Well, that doesn't meet our requirements. Lock and key model. Yeah, that's more like it. DNA pairing model. No. Sliding clamp model. No, that doesn't sound right either. So B is our answer. Let's move on. What does it mean when an enzyme is denatured? And we just said this up top. It becomes stronger? No. Complete opposite. It breaks down into glucose? No. It changes shape and stops working? Yes, it changes its shape and as a result, its function. It can't function anymore. It turns into a lipid? No. Let's move on. This is fun. Which two conditions most directly affect enzyme activity? Well, we actually talked about this. It's temperature and pH. And we will talk about what pH is and really all of this. So light and sound, no, that doesn't sound right. So light and sound, wrong. Temperature and pH, yeah, that sounds more like it. Those are what most directly affects enzyme activity. Water and salt? No, that doesn't sound right. Sugar and oxygen? Nope. All right, so B is our answer. On to the next one. Why are enzymes considered specific? Well, enzymes are specific just because really they only bind to specific substrates, as we just talked about in the last question or so. So they only work in animals? No. They only work with one type of substrate? Yeah. Yeah, they only bind to specific substrates with specific shapes. They only work at night? No. They work at day too. They change the pH of all solutions. No, that doesn't sound right either. All right, let's do one more. Which of the following is true about enzymes? This is like some trivia that we should know. All right. Enzymes are used up after one reaction. Well, no, actually, we said that enzymes are actually reused in reactions, and they can bind to other not types of substrates, but other substrates that fit into the type of substrate that they are looking for. So enzymes are used up? No, they're not used up after one reaction. Enzymes change shape with every use. No, that doesn't sound right. Enzymes stay the same. Enzymes can be reused many times. Yes, yes. Enzymes are made of DNA. No. So C is our answer.